All right, this is objective 2, so we're looking at objective 2 part 4, and this is the second part. So if you haven't seen the first part, please turn this off and go watch the other one first. All right, what we're going to do now is we're going to look at how do we find the slope of a line given its equation. The first form that we're going to look at is slope-intercept form, which I showed you in class because I showed you how to graph using that. Slope-intercept form, like I said, is my favorite form of a line because it gives you so much information. First of all, we have m, which is right in front of x, and we also have b. Remember, m is a symbol for slope, and b is your y-intercept. And I do want to point out that you write your y-intercept 0, whatever b is. All right, so in this example below, we have y equals 3x minus 4. The 3 is the slope, and the negative 4 is the y-intercept. So if I were to graph this, remember the first thing I would do is graph b. So I would graph 0, negative 4, and then I would use my slope to find the second point. Now m equals 3. I need to write that as a fraction when you graph because remember your slope is rise over run. So to graph the second point, I would go 3 units up from there and 1 over to the right. So that was just a quick review on how we would graph a line in y equals mx plus b. All right, this next example is not asking you to graph a line, but it's asking you to find the slope and the y-intercept of the line whose equation is y equals 5/9 x plus 3. So, because we know that we have it in slope-intercept form, and the reason why I know that is because y is isolated. If I look through, I can see 5/9 and 3. M is the value in front of x, so my slope is 5/9. B is 3, but we don't leave it like that. We write it up as 0, 3. So my y-intercept, the place where it crosses the y-axis, is 0, 3. This next one says find the slope of the line. Well, this line is almost in standard form. Remember standard form, I'll write this down for you. Standard form is ax plus by equals c. We have to rearrange it because right now I don't know what the slope is. So the first thing I'm going to do is rearrange the line so that it is in y equals mx plus b form. Okay, so I got to move the 3x over. I'm trying to isolate y. That's why I did that. Now, if I look at negative 3x plus 3x, that cancels out, and I'm left with 2y. And on this side, I'm going to make sure, and I put 3x in front of the 11. The reason why I did not add 11 and 3 is because they are not like terms. The 3x is different from 11, so I have to leave it set by itself. And once again, I'm putting it in front because that's the way the form reads. The last step I have to do to get y by itself is divide everything by 2. And I mean everything. So this becomes y equals 3/2 x plus 11/2. Now it's just asking me for the slope of the line. So all I have to do is read off whatever's in front of x and put that answer down. So m equals 3/2. Okay, second line, line B. It says negative y equals 6x minus 7. All right, we almost have y isolated. We're almost in y equals mx plus b. I notice we have a negative in front of it. So just like I told you before, you're going to divide by negative 1, which allows you to change every single sign in the problem. Okay, now that I've changed all of the signs, I can read off my slope. M is equal to the value in front of x, which is negative 6. And that's it. Let's move on. Objective 3, finding slopes of horizontal and vertical lines. We've already talked about this, so I'm going to go through this kind of quickly. If you have a horizontal line, Remember the horizontal line, the formula for it will be y equals some number. And for all horizontal lines, the slope equals 0. So we talked about walking on a treadmill with no inclination. That slope is 0. So here's an example. Find the slope of a line y equals 3. So y equals a number. I don't have any x's. I know that this is a horizontal line. And it might be worth drawing really quick. So we have x and y axis. And I go up to where I find y equals 3. I put the line in. And I see that the slope equals 0. So the answer for this is m equals 0. Okay, next. Slope of a vertical line. A slope of a vertical line goes with the equation x equals a number. That's the equation of a vertical line. So as we said in class, a vertical line has an undefined slope. That means that you're not able to walk up a wall. Okay, the slope is undefined when you have any vertical line. So here's an example. Find the slope of line x equals -2. Okay, so if I were to graph that, it's not asking me to do that, but I just want to show you what it looks like. X equals -2 is this line I just drew. And we can see that it is a vertical line. And when you have a vertical line, the slope is undefined. Okay. All right, objective 4, slopes of parallel and perpendicular lines. Okay. So for parallel lines, and there's an example right in front of you, the two lines are parallel, which means they have the same slope. Okay. Also, vertical lines are parallel lines, however, their slopes are undefined. Remember, if it's a straight up and down line, then we have undefined slopes. But otherwise, if they are not vertical lines, and they're on a slant, if they have the same slant, which is the same slope, then they're parallel lines. Perpendicular lines are ones that cross each other and basically create a 90-degree angle. And the interesting thing about this is their slopes are negative reciprocals of each other. Okay, so let's discuss what that means. Negative means opposite sign, and reciprocal means to flip the values over. And if you want to double check if you have the right slopes, you can take the product of the two slopes and it always will be -1. So this is kind of the check to make sure you have the right ones. As we can see in the picture, the slope of the first line is a and the slope of the second line is -1 over a. So here's an example. Determine whether the line 6x plus 2y equals 9 is parallel to -3x minus y equals 3. All right, what you have to do is place both lines in y equals mx plus b form. So I'm going to call this line number 1 and line number 2, sorry. So line number 1 is 6x plus 2y equals 9. I'm going to subtract 6x off of both sides. I get 2y equals -6x plus 9. I'm going to divide both sides by 2. And I get y equals -3x plus 9 halves. Okay, so the slope of my first line is -3. Line number 2. -3x minus y equals 3. I'm going to add 3x to both sides because I need to remove it off that side. I get -y equals 3x plus 3. Now I have a negative in front of y, so I'm going to divide by a -1, which allows me to change all of the signs. And I see that m is -3 as well. So when both the slopes of the lines you're looking at are the same, after you place them in y equals mx plus b, then they are parallel lines. So the answer to this is yes, they are parallel lines because their slopes are the same. Determine whether the following lines are parallel, perpendicular, or neither. Okay, so this is line number 1 and this is line number 2. Place them both into y equals mx plus b. So I'm going to work on number 1 first. Negative 5x plus y equals negative 6. I'm going to add 5x to this side, add 5x to the other side, and I get y equals 5x minus 6. M equals 5. Okay, second line. Do the same thing, move it into y equals mx plus b. I'm going to subtract x off of this side, subtract x off of that side. So I get 5y equals negative 1x plus 5. I added the 1 in front of the x just so I could see what it looks like. And then I'm going to divide everything by 5 to finish the problem off. So y equals negative 1/5 x plus 1. Okay, if I look at that, I see that my slope equals negative 1/5. Okay, to see if they are perpendicular, they have to be negative reciprocals of each other. So check, are the signs different? And the answer is yes. Are they reciprocals of each other? 5 is 5 over 1, and the reciprocal of that is 1 over 5. So since the signs are different and the values are reciprocals of each other, the answer is they are perpendicular. If the slopes were the same, the answer would have been parallel. If the slopes were not opposite reciprocals of each other, then you would say neither. And finally, this is the last objective, slope as a rate of change. So the average price of an acre of mid-grade Iowa farmland in 2008 was $2,300. In 2012, the average price for mid-grade farmland was $8,300 per acre. Write the two as an ordered pair. So the first one is going to be 2008, comma, 2,300. And the second point is going to be 2012, comma, 8,300. Find the slope of the line through the 2 points. Okay, so we just have to change the slope. So I'm going to use a different color so I can name them. All right, so this is going to be x1, and the second one's going to be y1, and then this is going to be x2, y2, signifying the second point. Okay, back to our ink. So I'm going to use a slope formula, which is y2 minus y1 over x2 minus x sub 1. Okay, so if I do that, y2 is 8,300 less 2,300 over 2012 minus 2008. And when I do this, I get 5,000 over 4. And if I divide 5,000 by 4, I get 1,250. So what does that mean? That is the average rate of change of the price of land happening per year. So there's been an increase, because it's positive, of $1,250 per year of that particular farmland in Iowa. Okay, and that's it. You are officially done with Objective 2, Part 4. There will be one more video explaining Objective 2, Part 5.